In lesson 6, we're going to focus on the distance between two rational numbers. Now, rational numbers are just basically any number you're familiar with. Integers, fractions, decimals. And if we want to know how far apart they are, which shouldn't seem so hard, except the fact that we're going to throw in negative and positive numbers. So let's just jump right in, as we always do, and we'll talk about what it all means. Person A here. I guess there's person A and person B. What is the distance between -4, which occurs right here on the number line, and 5, okay, which is over here on the number line? How far apart are they? 1, 2, 3, 4, 5, 6, 7, 8, 9 units. They're 9 units apart. Okay, and it's really important that we understand that, because a lot of times we look at it, well, how far apart -4 and 5, and we confuse that negative, and we'll say, oh, they're 1 unit apart. Well, no, -4 has to go to 0, and 5 has to go to 0. That's 4 and 5, that's 9. All right, but what if we just change the order and we do 5 first and -4? We go from 5 to -4. Hey, guess what? Still 9 units. Okay, it doesn't matter which one we write down first. They're always going to be 9 units apart. But that's a positive and negative. So what about two negatives? So I will plot -5 here, and I will plot -3, and I will see that they are, well, I'll try to show you that they are 1, 2 units apart. What is the distance between them, right? And what about -3 and -5? We switched around. Think there's going to be a difference? Nope, they're still 2 units apart. All right, how about 7 to -1? 1, 2, 3, 4, 5, 6, 7, 8 units. And what about 1 and 7? Maybe. So if I get -1 and then I go to 7, it's 1, 2, 3, 4, 5, 6, 7, 8 units. Now remember, we're talking about distance. The distance, remember, that's like saying absolute value, right? The distance between something, the absolute value. And in absolute value and distance, we're not concerned if it's positive or negative. We want to know how far apart things are. So we're going to make a little statement down here. Because the endpoints, -4 and 5, -4 and 5. Because the endpoints are the same. As always, guys, sorry for my sloppiness. Because the endpoints are the same, the distance between them is the same. It doesn't matter what directions we go. If we're going from -4 to 5, or if we're going from 5 to -4, because we're talking about distance, and distance doesn't matter. Direction doesn't matter in distance. So because the distance between the endpoints is the same, or because the endpoints are the same, the distance between them is going to be the same. So let's get into some examples here. And I'm going to we're going to come back. Let's do these, and then I'm going to come back and show you maybe a different way to do them. Okay, so just real quick, what is the distance from 0 to -8? So if I go from 0 to -8, it's 1, 2, 3, 4, 5, 6, 7, 8 units. What is the distance between -2 and -1.5? Well, if I go from -2, here's -1, -1.5 is going to be right here. If I go from -2 to -1.5, that's only going to be half a unit difference. Leave some space, because we're going to come back here, because we're not going to do this on a number line every single time. Distance between -6 to -10, I'm going to go to the left. 1, 2, 3, 4 units. Okay. All right, I'm going to do that real quick, and we're going to come back to it here in a second. Because I want to go to this example, because there's a formula, and we're going to test that formula back on those 3 that we just did. The formula for the distance between two rational numbers. It says find the distance between -3 and 2. So we start on an endpoint. Okay, here's -3. Count the number of units from the endpoint that you started with to the other endpoint. Okay, 1, 2, 3, 4, 5. 5 units. That's what we've been doing. But we have a formula. So using the formula, which is right here, okay, this is our formula. For two rational numbers, P and Q. P and Q, remember, variables. They're representing any unknown number. The distance between them is the absolute value of P minus Q. So using this formula right here, if I have -3 and 2, okay, I can say that the absolute value of -3 minus 2 is going to equal 5 units. So let's test it. Using what we did in lesson 5, if I were to keep change subtraction to addition, I'm going to keep the -3. I'm going to change the minus sign to a plus. I'm going to change 2 to a -2. Well, then I'm going to add -3 plus a -2. Remember, it's both negative. We add them together. We get 5. Since they're both negative, they stay negative. And what's the absolute value of a -5? How far away from 0 is -5? Well, it's 5 units. That's what we got. But what if, let's see this one. What if we change the order around? Does it matter? Which one's P and which one's Q? Well, let's test it. What if I took the absolute value now of 2 minus my -3? Well, change the minus to a plus, change -3 to a +3. We get the absolute value of 2 plus 3, which is 5, and the absolute value of 5 is 5. So it doesn't matter, okay? We can find the distance between 2 points by using this formula right here. And it doesn't matter which one you put as P and which one you can put as Q, because remember, if I scroll all the way back up here, we said because the endpoints are the same, the distance between them is going to be the same. So it doesn't matter which one you put first. So this is why I wanted to come back up to these problems here. So we've done it on the number line. Let's test and see if our P minus Q thing works, right? Oh, I lost my blue, so we'll use purple. Okay, so again, I'm using P minus Q. I'm subtracting the two numbers and taking the absolute value. So I can go 0 minus -8, absolute value of that. Keep, change. I get the absolute value of 0 plus 8, which is 8, and the absolute value of 8 is 8. Notice we get the same thing, but we can do it without a number line. Just to show you real quick, what if I change it around, okay? And just kind of squeeze it in here. What if I did -8 minus 0? Well, that would be the absolute value. You can change it to addition, but if you subtract 8 or try to subtract 0, add 0, you're just going to get 0. What's the absolute value of -8? 8. Okay, so that's what I mean. It doesn't really matter which way you go. So, picking away here, maybe I'm going to say -2 minus. Now be careful with these negatives here. We're always subtracting the second number. I don't care that it's a -1.5. I don't like all these minus negatives here, so I'm going to keep the -2, change a minus to a plus, change -1.5 to a +1.5. Now we're going to add those together. Different signs means we subtract. Subtract ignoring the negative. And that ends up being, well, just a half. Since this is further away from 0, we get the absolute value of a -1/2, which just is a +1/2. Okay, so this distance, this formula here, just real quick, I'm going to take the absolute value of -10 minus a -6. This one might be a little easier to see because there's no fractions. keep the negative 10, change a minus to a plus, change negative 6 to a positive 6. Remember our rules. If they're different signs, we subtract. 10 minus 6 is 4. Then we keep the sign of the one with the greater absolute value, negative 10, so this will be negative 4. And the absolute value of negative 4 is just 4. Anyway, this formula here, guys, is going to help us find the distance between 2 points. And what I want you to take away is that it doesn't matter which one comes first, because if the endpoints are the same, then the distance between them will be the same.